Okay, so I'm looking right now at the first box about how to solve exponential equations. But like I wrote at the top, it's actually something we've seen before. We've seen it actually a couple of ways, in fact. We saw it just rewriting things in terms of the same base if possible, which in this case it would be possible. Or the other way we saw how to do this is using logs, right? Logs as an inverse function. And we did that when we did the inverse functions. We're trying to find inverse functions. I think that was like 2 homeworks ago. So, okay, we could, of course, write this as 3 to the old way was write this as 3 to the third, right? And then just say, oh, x is equal to 3. The other way is to look at it like this. A new way, or not really new because we did it before, but just look at the base value here and then take that same log. Log base 3 of that and log base 3 of that. Log base 3 of that is going to undo the 3, so you just have x, right? And then now you just solve log base 3 of 27, which is 3. So that's the idea. Now, sometimes it's not going to be a nice number like this. Like, what happens if this was 25 instead? Then I wouldn't be able to write it like this, right? Let's say this had been 25. This is 25. Then I wouldn't have been able to write it as 3 to the x is equal to something. That's not a really nice number, right? 3 to the x equals to 3 to the what is 25? I don't know. That's actually just answering the original question. So I don't really get any new insight there. So I'll just leave the original question mark. I don't know what to do with that. On the other hand, if I was to do it this way, using the log base 3, so if I look at my original equation, and 3 to the x is equal to 25, I can still use that same idea, right? And just to do log base 3. I just erased it and wrote it down again, but same thing. And then this would still give me x. This side I have log base 3, 25, and this is actually a legitimate answer here. This is the exact answer. If I want an approximation, I can use the change of base formula and just rewrite this in terms of some of the logs that I know, ln or common log. So this is ln 25 over ln of 3. And then you just plug that in to the calculator. It should be, I might as well do it. Okay, let's see, ln of 25 divided by ln of 3, and that's about 2.9299. And not surprisingly, it's close to 3, right? Because remember the answer when it was 27 was 3. So if I make it a little lower, then it should be something a little lower. That seems to make sense. Okay, that's the idea for the first 5 questions. Let's try the first 5. Okay, number 1 is 2 to the x equal to 16. And I'm going to do number 2 at the same time. Actually, no, never mind. I'm going to do 2 and 3 together. So let's just do 1 first. All right, let's do it approaching it the new way that we just sort of relearned just now. So it's going to be log base 2 of 2 to the x is equal to log base 2 of 16. And this guy just undoes the x, right? So it's just going to be x. And log base 2 of 16, 2 to the 4th power is 16, so x equal to 4. That's it. Well done. In the notes, I mentioned that you could use ln if you want to instead. I think it's probably simpler if you just stick to the base. But if you're curious how I could use ln, let me just show you once real fast. And let's say you didn't know how to solve log base 2 16, then you have to use the change of base formula, right? So we can get around that a little bit by just starting with ln2 at the beginning. So I start with ln at the beginning, then I can use my rules of logs and just pull that x out to the front. So that would give me, now let's do black. So that would give me x, ln of 2 is equal to ln of 16. Right? And to solve for x, I just divide by ln of 2. So x is equal to ln of 16 over ln of 2. And then this is something that you could plug into your calculator, and you'll see that it comes out to equal to 4. So if you don't want to even think about solving a log like this, you can just plug it into your calculator straight. Yeah. Even at this stage, I could have rewritten this as log base 16 over, natural log 16 over natural log of 2. So I could have gone from here to that position as well. Anyways, that's number 1. X is equal to 4. Did you guys get that?
Yes.
Yeah, okay. Let's look at numbers 2 and 3 then. Look at these together. They're the same question, just one says find the exact answer, one says solve the give the approximation. So the question is 3 to the x equal to 5. And we'll go straight down. I'm going to write the exact answer, and then I'll write the approximation. So to solve this, we're going to take logs of both sides again. All right, let's do log base 3. Log base 3 because that's the base of this guy, right? So this 3's will undo each other. I just get x is equal to log base 3 of 5. And that's the exact answer right there. So that's the answer to number 2. Now for the answer to number 3, I'm just going to evaluate this on a calculator. So I'm going to rewrite it first with a log that I have in my calculator. So natural log of 5 or natural log of 3, and then I just plug it in. Okay, so I'm going to just plug it in my calculator here. Natural log of 5 divided by natural log of 3. And I got 1.46497. Or to the nearest 3 digits, let's say 1.465. I'm using the squiggly equals here because it's an approximation, not exactly equal. So squiggly equals approximate. Okay, so far, guys?
Yes.
Okay, great. So we just have 2 more of this type, and then we'll take a mini break and move to the second type. Should be done real fast. Okay, number 4 says solve 2 to the x minus 1 is equal to 1/4. All right, same approach. Yeah, same exact approach. I'm going to take log base 2 on both sides. So it's going to be log base 2 of 2 to the x minus 1 is equal to log base 2 of 1/4. And on the left side, same basis, so it just comes out to x minus 1. It just undoes the function. I get the exponent back. On the right side, log base 2 of 1/4 is 2 to what power is 1/4? Well, it's negative since it's in the denominator, right? So it's going to be a negative something. And 4 is 2 to the second power, so negative 2. 2 to the negative second power is equal to 1/4. But let's say you didn't see that. You could also just have plugged this into a calculator, ln of 1/4 over ln of 2. Here, I'll show you that that actually does, in fact, work. Let's see. I don't know if you can see my calculator, but I'll show you the screen afterwards. ln of 1/4 divided by ln of 2. And you'll see that you get negative 2. Let's see if you can read that. Can you read that? ln of 1/4 divided by ln of 2 is equal to negative 2. So you could have just done that. No, I'm not completely finished because I haven't solved for x itself. So I just had to add 1 on both sides. And x is equal to negative 2 plus 1 is negative 1. So there's your final answer here. Okay, cool. It's kind of fun, right? It's kind of fun. Applying the inverse functions, coming out nicely. Yeah. I don't know. I might be peculiar, but that I find this a little bit fun. Okay, number 5. Solve 3 to the x plus 1 is equal to 81. Okay, let's do this one without having to think. So let's just skip straight to using the calculator instead of, even though I know 3 to the, what was it, 4th power is 81. Let's just pretend I don't know that. So I'm going to take the log base 3 on both sides. And I'm going to get x plus 1 then is equal to log base 3 of 81. But I want to rewrite that as x plus 1 is equal to natural log of 81 over natural log of 3. And I'm just going to plug those things in. And I'll show it to you again on the calculator, even though I know that's 4, but let's just pretend again I don't know. Okay, so here it is. Natural log of 81 divided by natural log of 3 is equal to 4. That's the next line. X plus 1 is equal to 4. And I subtract 1 on both sides, and x is equal to 3. So that is it. That's number 5. Take a pause with the recording.